So actually, the talk I bring today is about very important for the AI infrastructure. If we really want to look at the OpenStack or Kubernetes, if you want to use that to support more different kinds of AI hardware, then I think that this talk is very, very related to how to enable different hardware to support AI, especially, for example, the large model inference or large model training. And here is the very quick self-introduction. Actually, I'm not working for the basic academic of AI, but in the past more than 17 years, actually, I've worked for IBM research, and especially for the IBM system research. Okay. So many years, actually, we have a lot of contribution to OpenStack. But after a while, since when we want to use more and more GPU, we want to do the GPU virtualization at that time, yes, we changed to the Kubernetes container technology because that's more easier for us to do the GPU virtualization and also the FPGA virtualization. And that's in the year of 2015. So okay, back to the system side. Today, here, actually, we want to see if compare the human brain and AI chip. Still, you can see human brain have much larger the scale of the synapses, and 50 times compared with the GPT-4. Okay, and also actually the more memory than a single chipset. But if we look at the power consumption, it has around 500,000 times power efficiency than the AI chip. And in the similar intelligent level, actually human brain, actually today we learn much less data compared with the AI chipset. So that means that we still need a lot of innovation to do the AI system innovation, especially for the chipset architecture. But you all might know that today in global have a lot of innovation in the AI architecture. Actually, when I worked in IBM at that time, at least 10 years ago, we have a different department to work on the different kinds of AI or deep learning accelerator for power, for mainframe, or standalone. Any of you from IBM?
No.
Good. Actually, I met a lot of have the existing experience in IBM or previous experience in IBM. Okay, good. No, okay. So, but a lot of issue is not in the hardware side. Even we have the best hardware, computation hardware today, but we cannot largely deploy in the industry. You might all know that that is because the software ecosystem. Yeah. That means, for example, today, if you look at the NVIDIA, they are very successful. Any of you come from NVIDIA? Good. Okay. So they very successful, not because the chipset, because CUDA. They have invested more than 20 years in the CUDA, more than $10 billion US, and they have millions of developers in the whole global for CUDA. But for other companies like an AMD, Intel, Huawei, or other chipset vendors, they don't have this kind of huge dominant ecosystem. So today's system architecture, systems are very vertical and fragmented. They have the different architecture so that they have different instruction, so that they need a different compiler, then they have different library. So for any of the end user, it will be very headache if even you build a system, even you have the OpenStack can manage the different hardware through your PCIe device, okay? But you still cannot solve the problem of the user. Even you give them the hardware, it can be scheduled, but they download from the open source model or code can only run on CUDA. Okay, so that's the major concern, major issue. So that's why I talked to OpenStack, some development leader today in this conference, that I say to only solve the issue how to connect with the PCIe or the unified hardware interface is not enough. Okay, the issue actually is from the upper layers stack. So that's why we call it as the open compute. Very simple, open compute for AI. It is we want to build together with global we want to build a unified but open source, totally open source software stack. Can run those AI models on different hardware. Different hardware means different AI chipsets and different type of hardware. It can be the edge device, it can be the PC, AI PC, or it can be the server or bigger node, or in the cloud, okay? So we believe that this open compute, if we can build, then it can help the user, developer, vendors, you can have more choice on the hardware and lower the cost. And on the other hand, it will allow the hardware company, they can focus on the next generation hardware architecture innovation. And they don't need to always worry about the ecosystem concern. Any of you come from any chips or processor company? Okay.
No.
Good. Okay. New user. Okay, good. Because today a lot of chipset company, they worry about that. Even they have a huge investment on the next generation chip, but if they cannot be large scale deployed in industry, how they can get back the investment? So that's the major concern. And also we have recently have more global discussion on the open source community. And in this year, we have a lot of discussion a lot of activity actually in Paris. I came here several times this year. Open Source Strategic Forum this year in Paris, that is GoSim, one day before GoSim. We met together with Linux Foundation, PyTorch, Eclipse a lot. And people, and also we have in Geneva later this year, and also we have the meeting with United Nations. A lot of people do think that we need more country and region can access the AI capability. But today the computation cost is still too high. And we know that in global have a lot of data center have lower utilization. For example, since the AI chipsets actually have a very fast evolution. So for the last or the 1 or 2 version earlier, then the utilization might be low. So can we group those kinds of different lower utilization resource and provide them to the developer and the university in global? Yeah, that's a good idea, but the key challenge is because the infrastructure, especially the chipsets, quite different type. So we don't want to let the user have the very high barrier to how to use that. So can we also have these kinds of open compute? So that's a lot of discussion in global. Then let me give you something. Yes, actually in the past 3 years, we BAAI actually worked together with Peking University, Tsinghua University, a lot of different open communities, build this, we call it the FlagOS. The OS is not stand for operating system, it's not the operating system, it is the open software. Okay, open software. And actually, this is the unified system software to target to run the PyTorch and also the different large model on different AI chipset. So it contains the different very important libraries, have the unified AI compiler, have the largest AI operator library written in Triton, also, and we have the framework and the communication libraries. And also we have the tool. Currently, this stack can already support NVIDIA, AMD, NPU from Huawei, GPU from more others, and also we support the RISC-V AI, and also the ARM, they also expanding the AI instruction. So we can support the chipset used in the data center and also the chipset in the edge device. But even we have this stack seems comparable to CUDA, okay? But we cannot solve the problem. Why? 2 additional challenge for open compute. One is today, most of the AI models, actually more than 95% on typing phase, open source with CUDA only. And AI developer today, to develop the AI application today, they don't have any skill to migrate the AI model from one chipset architecture to another one. That's very, very challenging. Okay, even if you provide all different layers technology. Okay, so how to deal with these things? How to make our user easier? Okay, the idea actually is for you by using the OpenStack, you build a cluster not only with a media chipset but also can come from other vendors. You want a user very easily to use your infrastructure to run the AI model, to run the different AI model. So that's why the talk today is about this FlagRelease. I highlight. That's the tool. Okay. Actually, this idea is come from the CPU side. I mentioned I worked for IBM many years, and IBM, you know that we have the power processor. Always want to compete with Intel, but not success. We have the mainframe. Mainframe is dedicated hardware as well. So you know that in CPU, actually they already have evolved for more than 40 years. Mm-hmm. And they today have more than 80 different architectures till today. How they solve this problem, right? How they run different architecture, how they run the MySQL, how they run the Apache web server, those open source software on different architecture. Actually, it is one of the mechanisms is in the Ohio State University. They built the open source cluster, have the different major chipset server, CPU server. And they support the Linux Foundation and Apache Foundation, the more than 100 or 200 different open source code. And they do the CI/CD to do the migration testing and release the open source version. So that's why you today can see a lot of open source software have the different version, very quick different version evolved, but still have the different, for example, /x86 or /PPC or /others. So the user for the CPU side, they don't need to migrate by themselves for this major open source project. They just download and run. Okay. So this is the idea. We want AI for AI. We wanted to do the same thing. So that's what the target for the FlagRelease. We just download the original, the open source model from Hugging Face or ModelScope. ModelScope is the Hugging Face version in China. Download it. And to do the task identity, to analyze the dependency, to do the migration onto the different hardware. And after the migration, since the underlying library compiler all have been changed, and the hardware have been changed, so we need to do the very careful evaluation before we release. Since underlying all the software, including hardware change, we need to ensure after this migration, the migrated model run on the new hardware have the same performance as that one with CUDA on NVIDIA. Mm-hmm. We cannot let the user lose any accuracy because use the new hardware. We need to ensure the accuracy. Okay, so that's why we also have the model evaluation, and after all the testing, we release the back to the Hugging Face and ModelScope. So this is the FlagRelease. Yeah, okay. And the underline, we have the group, the different chipset architectures, chipset server in the cluster. We support the local cluster and also some remote one. Yeah. Mm-hmm. So yes, we only today we rely on Kubernetes, and we want to expand this capability with the collaboration with OpenStack as well. Okay. But to do this, actually, if you notice the title, I call it the semi-auto migration. Mm-hmm. Because this idea is come from my many years work in IBM. I worked for power research for a long time. We always had the dream to automatically migrate the code from x86 to power. Okay. Mm-hmm. But a lot of since the open source software is a lot of open source software, so very difficult. But this time, I still have the dream. If I can migrate the model from NVIDIA CUDA onto the other architecture. Okay. But so that's why the final target is auto migration. But today, yes, we can only do the semi-auto migration. And don't ask me how is the percentage of the semi, okay? Mm-hmm. But here, yes, we need to handle a lot of challenges. Hardware always have the slow or unstable network or the unstable hardware. Compressing that's migration dependency. This is the major challenge. Since different chipsets today, they have the different vendor, for example, not only the model. You might have heard about VLLM, right? Yeah, VLLM, they have a lot of different fast version release. But their release only support the NVIDIA, okay? And the other chipset vendor, they need to hack the VLLM in their own way. So each chipset company, how they hack the VLLM, how they change that, the way is totally different. And their version to support the VLLM is also different. Some is still the very early version, some are already become the latest version. On the other hand, the model, since the model from QN, model from DeepSeek, model from, we also support the OpenAI GPT OSS. All the model, when they define the algorithm they used, it's also very different. So on one way, we need to analyze the chipsets, how they change the code. On the other hand, we also need to analyze the model, okay? And quality control, okay, a lot of challenge. But at least we do something. Besides we have manually, of course today we can manually do that, but a long time, right? Usually it needs us 1 or 2 weeks to finish one model migration. So we start to use some AI things. So yes, we use the FlagRelease agent. The agent is, it will help us to, once we have the error, detect the error, the agent will help us to automatically do the environment analysis, and also through the connection with the local knowledge base, and also some other toolkits, then to figure out how to deal with, and then start to do the repair and feedback, okay. And here is some of the results of our repair. Currently we can do the automatic detection, automatic repair, and also the automatic verification and feedback. These are 3 very typical things if you start to try to use the AI large model or agent to do that, very similar. But today, on the right-hand side, we also summarize the 5 major things, and for different successful ratio, okay? Some of the error can be handled in high ratio, but some of them still the very low ratio can be automatic fixed, okay? But that's not the major things. The major thing is, even with all the agent, still how we do the migration, that's the core piece. Let's see the invocation path for CUDA, okay? The core path, okay? Today, if you have an AI model, then first you will call the acceleration framework like VRM or SGLang, okay? Then you will call the PyTorch, okay? Then the PyTorch will call the CUDA library, operator libraries, and also the communication libraries, like the Nickel, okay? And also the underline have the CUDA compiler. Then it go to the NVIDIA's GPU hardware. So this is the core path for today. Okay, what we need to do is, since the final part is not the only NVIDIA, have also other chipset. So we change the framework, the first step framework change to the FlagScale. That's the framework, acceleration framework from FlagOS. PyTorch, we keep the PyTorch, no problem. Then the operator library, the CUDA library, we change to the FlagGEMs. That's the Triton library we developed. Communication library, we change to the FlagCX. It already can support the more than 10 different chipsets from vendors. And finally, the compiler, we already developed one enhanced compiler based on the Triton compiler. Okay. So by this different piece, that's how we can really do the migration. So this is the core piece. Okay. So let me very quickly to introduce one by one. The library, okay, that's the very important. In the AI algorithm development, those developers, they will not develop the algorithm from scratch. They will call different library to build, to orchestrate, to combine the libraries for their new algorithm. So the library is very important. And today, for us, the FlagOS, we have the FlagGEMs. I guess anyone heard about the Triton language?
Language, which one?
Triton.
No.
Okay, yeah, actually that is the language 2 years or 3 years ago, open source by OpenAI. Yeah, because they also want to have, besides the CUDA, the CUDA C, they also want to have a Python-like language to very easily to develop the new algorithm on NVIDIA or AMD other chipsets. So currently become the second popular language for the AI algorithm development. The first one still is CUDA C. Okay, this is the second one. But one of our contribution is we build the largest operator libraries by using the Triton, and even get even better performance than CUDA. For example, we for these 200 different operators, we compare apple to apple, compare the performance on the same NVIDIA hardware. We can get a better performance than CUDA. Okay, and also we also work together with different other architecture AI chips. Then we even can get a better performance with the proprietary handwriting the code. Okay. So in this year, PyTorch Foundation, they include our library into their ecosystem. That become the first can support the multiple chipset library in open source. But only the library is not enough. Actually, the compiler will play very, very important role. Okay, so this is the AI compiler, FlagTree. It already can support the different architecture, instruction architecture, and even we still support the Triton language, but compared with the original, the OpenAI's Triton compiler, we can get a much higher performance. You can see for the Q1 data model. You heard about the Q1, right? Yeah. So significantly increase the performance. So currently, by using this open source stack, we can achieve very close to CUDA's best performance. Okay.
Wow.
Besides, another thing actually is a framework. You know today, for no matter the training or inference, for your user on the cluster, on the cloud infrastructure, if they have the cluster, if they want to deploy the model, okay, today have a lot of different kinds of model. Have the language model, have the multimodal model, have the dense model, also have the MOE model, okay? The model is quite different. If the chipset is different, and also the cluster might also different. For example, you might have the cluster only have 10 nodes, or have the cluster have 1,000 nodes, quite different. So currently, from the view of optimization, parallel optimization, we cannot rely on the single expert to understand all these kinds of difference. Okay, so that's why we enable the FlagScale. It's a framework can support both the training and inference on different hardware. But very unique value is automatically to do the optimization. Okay. So that means that your user don't need to worry about how to do the parallelization on the given cluster. They just run the FlagScale. And currently, we also compare it with the human experts result, has a better result already. Okay. Recently we have the one experiment. Real experiment is one server manufacturer. They just come out a new architecture with the 1,000 compute node in the new architecture, okay, the super node. We just spent 10 minutes to automatically deploy and run the training for a very, very new multimodal model.
So fast.
Just 10 minutes to get a very good scale out performance. And the other thing for the inference is multi-backend support. Today you might heard about the Metron DeepSpeed, but VLM, SGLang, Llama CPP, these are quite different backend to accelerate the inference. But each backend comes from some smart open source project. But each backend have the different advantage, okay? So people, again, have another kind of difficulty to choose which backend should I use. which backend can give me better performance for my application, for my model. Okay. Here is just to give you some experiment that different backend, actually some will be good for the throughput, some will be good for the time to first the token. So the their advantage quite different. So that's why we also use this same framework to support the different backend automatically to give the good result for our user. The last, another one is FlagScale, is a communication library. You know the different chipset vendor, they have the totally different communication library today. And we build a unified layer, can talk to each communication library to become the unified communication libraries. And today we already have support the different chipsets. And lucky for us, 2 days ago in the Geneva ITU conference, it has become the new initiated standard. Yeah. But always we want to solve the more problem for the new developers. We still don't want to easy their work. So we also come out the Triton Copilot for to automatically generate the code for the AI operator. So if you imagine if you are a university or a model developer, if you want to have a new algorithm, just use this Triton Copilot. You just need to input the one description, then it will automatically generate the code. But not only that, after generate the code, it will automatically generate the testing code and help you to run on our backend real system and come out to compare the accuracy, compare with the NVIDIA, to ensure the accuracy and also the system throughput. So it's much, much beyond the ChatGPT. ChatGPT today can only provide you the code, but cannot guarantee the accuracy or how fast. But for us, we already do that. And it is now supporting the different hardware architecture. Okay. But for us, actually this is a new area. It is AI for system. AI for system infrastructure, or AI for system research. So we just passed the first phase is the AI augmented development to help the developer to have the copilot like the tool to do that. But our goal is by using more and more AI technology, we want that this FlagOS whole stack and also the migration can totally automatic to do that. Okay. But of course, we have a lot of challenges. The first one is very difficult is because we want to solve the problem not only for single architecture, but different architecture. So how to generate the code or the solution good for different architecture, that is very challenging. And today for this FlagRelease, back to the current FlagRelease, we already can support migrating model, have all the list one. So you can see the most of the latest one already migrated, and people on this URL can directly get it. For example, here it just give you some screen copy, and yeah, people go to the Hugging Face and can find the model's name and the hardware name. They just download that. Yeah. Thank you. You can directly go to the link. Right. And the more important is we open source release the migrated code, migrated the model, and also the Docker environment. Docker environment very, very important. And so our user just 3 steps. Download the Docker environment, download the Docker environment, install and run. And then on their new hardware environment, they very easily can run that. Okay. Yeah. Because we don't want them to do the migration by themselves. And also, I mentioned that we also ensure the accuracy. That's very important for your user, right? So this is just to list out some on our README page. And you directly provide you the original, the CUDA, the performance accuracy number versus the new migrated accuracy number. Ensure the accuracy gap can be contained within the less than the 2% or even 1%. So to ensure the result is almost the same. That's very important. And by using this way, we also already support a lot of university in China, because in China we also have a lot of university that lack of the AI hardware. So we enable them with the different hardware to do the education. Okay, back to BAI, since I come from BAI. And in our research institute actually is leading the open source activity for AI large model technologies. We have open source a lot of large model, open source more than 100 different kinds of models. We also open source a lot of very important data sets. Still today, the most important open source data set for large model training in Chinese is continued open source by us. Okay. We also open source a lot for the evaluation technology, but today what I share with you is the system software. It's in this part. Okay. Mm-hmm. And we have a lot of collaboration with PyTorch, Linux, and after this talk, I will fly to San Francisco because next week there will be the PyTorch and Triton conference here. Mm-hmm. Okay. And back, this is the talk, and we hope through this FlagOS and FlagRelease, we can reduce the hardware barrier through the open compute and open source collaboration. Okay, thank you for your time.
From a helicopter view, for me, it's not a totally AI person. Do you think, like, for example, the FlagOS stack is like a compiler from, speaking to CPU analysts, it's like a compiler, and you try to compile, for example, all open source AI models on all offset of different hardware you have, and you contribute back to the models the changes needed to do that. Yes.
Yes, right.
There's the from like.
Yeah. That's the idea. Yeah, that's the whole picture.
And as far as I understand, you do this only for GPU. GPU type of architectures, right? Not CPUs.
Okay.
Because instructions will not support.
Actually, we start to support, for example, RISC-V AI. They have the matrix.
Matrix. So
yeah,
you have matrix operations to optimize. Yeah.
Yeah, right.
Without it, you
actually
physically do calculations.
Right.
Like that.
Right. You are right. So actually, if we back.
So it's something that supports matrix instructions.
Yeah. Right.
Gotcha. So anything that will exist, released with the matrix operations, you will going to try to be supported by your platform, right? So you want to remove NVIDIA to be.
Include NVIDIA.
Include NVIDIA, but in this case you can run everything.
Yeah.
If this will be supported matrix operations,
that's that. That's next step.
The idea is to actually to run everywhere, to have robot with any processor and be able to run LLM on any robot. Actually.
Yeah, right. That's the idea. Because today, for example, we also see that since we started this project for the data center. And recently we already started a lot of work on the edge. That's because of the robot. And you know that in the robot case, this cross-platform migrations will always happen. Because, for example, in China, some of the university they might only have some lower price NVIDIA cluster to do the training. Okay, but after the training, they need to deploy onto the robot hardware, and there they might only have the NVIDIA. Store.
Yeah, smaller with different instructions, and you have to adopt instructions and rebuild all the compilers to compile into simpler instructions to be installed on this robot. So you can install model to the robot.
Yeah, right. Actually, in PyTorch, in next coming Thursday in San Francisco on PyTorch, I will give another talk. To introduce how FlagOS support from cloud to edge for the embodied AI. That is for the robot.
Yeah.
Because we do see more these kinds of requirement for the robot. But back to this, yes. So no matter from NVIDIA to others or others to NVIDIA, we need to support. So that's why in our whole technical stack, the compiler, unified AI compiler, very, very important. And
I got you. So you can just take source code and compile it into instructions for different platforms.
Yeah, right.
Got you. And is it for inference or for training?
Both
For
inference.
both
Inference.
I have a little bit strange and dumb question. Well, you said that to achieve this whole idea, the OpenStack help you, but there's a lot of other open source hypervisors, and why the OpenStack and help you?
Okay.
Why it's better than with people or Cloud Stack or Salt Stack?
Yeah, good question. Actually, after 2000, I mentioned after almost 2015 or 2016, the last version we closely work with OpenStack is the M version. And after that, because we have more focus on the AI infrastructure at that time, the container become very important, Kubernetes, okay. And this is so actually why this time I'm here, right? So because I do think that OpenStack is such a huge community before, very, very successful huge community, especially
because of community.
Yeah, but because the AI infrastructure duration, maybe it shift a lot of opportunity to Kubernetes and others. So that's why I think, why not I bring this idea back to see, this morning I also talked to some Nova leader, Sean, and others, to say, yes, actually I want the OpenStack since many years ago, very successful OpenStack. I want the OpenStack to become the next step. Can it have more, embrace more idea and have a embrace broader spectrum for its infrastructure, not only limited to their current capability. For example, currently, yes, we actually haven't started any integration with OpenStack yet. In our cluster, we just use Kubernetes, right? Still, we want to see the idea how to integrate with OpenStack, but just like today, we are saying for multi-chip support is in this layer. OpenStack is in this layer. We can down a little bit, OpenStack can up a little bit, we can meet in some level. So this is to just start this conversation.
Okay, meaning you want, as I understand it, you want OpenStack to adopt your ideas and to make it more on its layer of abstraction, not on the example on Kubernetes layer of abstraction, but on OpenStack layer of abstraction. Yeah.
Yeah. So actually, I know that this community also still they currently is discussing it for the AI infrastructure. So currently has no conclusion because we just started this conversation. In which layer we still don't know. Or maybe need to start some new thing in OpenStack. Yeah. Because OpenStack just the name, right?
Yeah.
It can enlarge its very large adoption.
And that actually was my question. Have you also worked with other?
Not yet.
Not yet. Okay.
Not yet. Not with other yet.
Okay.
Of course, we have a lot of discussion with PyTorch, but that's not for this infrastructure level PyTorch. Sorry.
You mentioned FlagOS. This is OS, right?
It's the open software, not
open software. It's not OS. It's
I
thought it's Linux.
No.
Distribution that's actually. You can start, and
actually, we are now discussing with operating system companies.
Yeah, I understand. So you set of libraries that they can install.
Yeah, that's
and install on top together with